All right. Hi, everyone, and welcome. It's 10:30, so we can get started. And as people filter in, that's fine. So welcome to the 48th Great Lakes Phragmites Collaborative webinar. And this is our third webinar of the 2022 series. So I'm Teresa Granger, and I'm joined by my colleague, Sam Tang, from the Great Lakes Commission. And we are hosting the webinar today on behalf of the Great Lakes Phragmites Collaborative. Our presenters today are Melanie Croft-White of Fisheries and Oceans Canada, and she will be presenting Flooded Phragmites australis provides habitat for Great Lakes coastal wetland fishes. And we also have Prabha Rupasinghe of McMaster University, and she's presenting Mapping Invasive Phragmites australis in Lake Erie wetlands using satellite images. So before we get to our featured presentations, we'll go over a few housekeeping things just to review. So for those who may not be familiar, I wanted to introduce the Great Lakes Phragmites Collaborative. The Great Lakes Phragmites Collaborative is a partnership to link people, information, and action on invasive Phragmites. The collaborative is coordinated jointly by the Great Lakes Commission and USGS Great Lakes Science Center with funding from the Great Lakes Restoration Initiative. The collaborative facilitates communication among stakeholders across the region and assists in the development and management tools and programs and services of Resource Center for information on Phragmites biology, management, and research. The collaborative is led by a multi-agency advisory committee and applies principles of collective impact to advance the common agenda for Phragmites management in the Great Lakes region. So the Great Lakes Phragmites Collaborative is working towards advancing member strategies that are outlined in our common agenda. The common agenda, which you see here on the screen, is a big step towards aligning our regional goals and establishing a shared vision for change. The purpose of the common agenda is to clearly define the intentions for the collaborative, develop a shared understanding of gaps and problem areas surrounding Phragmites, and also highlight the work and strategies that we're working on or wish to work on. So you can learn more about our regional efforts and how you can get involved by visiting our website. And a big component of our work and one of the ways we engage with Phragmites managers is through the Phragmites Adaptive Management Framework, or PAMF. So PAMF utilizes participatory science to provide data-driven Phragmites management guidance through an adaptive management framework. What that means is we have established a way to learn from what Phragmites managers are doing and turn that data into manual guidance to help managers make efficient and effective management decisions. So we encourage anyone who's currently managing Phragmites in the Great Lakes Basin to consider joining PAMF. More information on PAMF can be found on the collaborative website, which is linked here on the screen. And if you are interested in joining PAMF, you should definitely take advantage of our guidance that you can enroll. We have free virtual training courses. We'll have a live webinar this spring. So follow the URL on the screen, and we have lots of ways that you can get started and learn more about the program. So if you have any questions, our PAMF team is always available to answer them. So you can contact anyone at PAMF at pamf@glc.org. And if you're interested in learning more about Phragmites management in general, you should definitely check out our resources on our website. We have a bunch on management guidance, and we have all of the recordings of our past webinars. You can also join our listserv, which connects hundreds of other professionals, and sign up for our bi-weekly newsletter, which includes a quarterly research roundup of academic papers published on previous months. And you can find the links of how to join the listserv and the newsletter on the front page of our website at greatlakesphragmites.net. Additionally, today's webinar will be recorded and uploaded to our YouTube channel and website. So you can definitely access this webinar again if you wanted to rewatch it or share it. You can access any presentations, past presentations on our website. You can also view and register for upcoming webinars by following the URL listed here. And of course, connect with us on social media. Feel free to tag us in your Twitter, Instagram, and Facebook post. Follow us at GLPrag. Okay, so before we get to our presentations, I want to cover a few logistical items. So in order to minimize potential interruptions and background noise, all of our attendees are already muted and will remain muted throughout the webinar. To save bandwidth, we ask all attendees turn off their camera, except if you're the speaker, of course. And we do encourage and accept written questions from attendees during the webinar. So please, if you have a question, type it in the chat box, signified by the chat bubble icon at the top of the webinar screen. You can see it circled here in the green. Questions should be submitted anytime during the webinar. Since we have 2 presentations today, don't wait to the end. If you have a question, just put it in the chat box whenever it pops into your head. We'll do our best to take all questions and comments during the webinar, but if you need to leave before your question got answered, we encourage you to visit the webinar recording to see your question answered. And if you're experiencing any technical difficulties, you can send a message straight through the chat box and direct that message to the host, or feel free to email us and someone will get back to you. And you can email us at phragmites@glc.org. All right, now all of that's over. It's my pleasure to introduce today's presenters. So presenting first today is Melanie Croft-White. Melanie is an aquatic science biologist with Fisheries and Oceans Canada. She completed her Bachelor of Science degree at the University of Waterloo, Canada, and a Master of Science at McMaster University. In her master's thesis, she created an index to determine the quality of Great Lakes coastal wetlands based on the aquatic plants found there. Her current research at Fisheries and Oceans Canada focuses on fish, aquatic plants, and water quality and nearshore habitats of the Great Lakes. And I'm also going to introduce our second presenter now, so we can go smoothly. And our second presenter of the day is Prabha Rupasinghe. Prabha is a postdoctoral fellow at the Department of Biology at McMaster University of Canada. She completed her Bachelor of Science with a major in botany and a Master's of Science in GIS and remote sensing at the University of Paradena in Sri Lanka, and a Master's of Science in Geology at Bowling Green State University. She completed her Ph.D. at McMaster University in 2021, where her research involved remote sensing-based analysis of Phragmites australis distribution in Lake Erie wetlands and wildfires of boreal forests in Alberta. She's currently working on remote sensing-based change detection of wetland vegetation in the coastal marshes of Eastern Georgian Bay. So thank you both so much for sharing your work today. I will transfer presentation control through to you. So we'll start with our first presentation. So Melanie, feel free to take it away.
Thank you. I'm just going to share my screen. And get started. Oops. All right, thank you for the introduction. And thank you for joining me today for my presentation titled Flooded Phragmites australis Provides Habitat for Great Lakes Coastal Wetland Fishes. So today I'm going to talk a little, I'm going to go through a little bit of background, but I know most of the attendees here are quite familiar with Phragmites, so I'll kind of glaze through some of that information. I'll talk about our study design, some of our findings, and some applications.
Melanie, I'm going to interrupt you for a second. I don't think I'm seeing your screen.
Okay.
Let me make sure mine is stopped sharing. Hold on. Okay, it looks like my screen is still up.
Go ahead and try sharing again. Oh, there we go.
Looks like it's just slow.
Okay, do you see that?
Yes, awesome.
Okay.
You're good to go.
All right, we'll start again. So I'll go through a quick outline. So I'm going to talk about some background information, some of our study design, our findings, and finally some applications. So the native Phragmites australis has been present in North America for several thousand years, as we all know, and the non-native Eurasian haplotype arrived in the mid-1800s. And we all know it outcompetes other emergent vegetation like Typha species and Schoenoplectus species. We also all know that it's a master invader. It prefers sandy soils, but can also be found in many other conditions. It spreads through rapidly growing stolons, has a very high stem density and biomass, and leaves and stems are unpalatable and indigestible. And it does not need to be in standing water in order to grow, and it can form dense monotypic stands. And we will be comparing fish communities between Phragmites and Typha and Schoenoplectus. So just a quick comparison with those other vegetation types. So Typha prefers organic rich substrates, can also form dense monotypic stands. It provides food and habitat for birds, mammals, invertebrates, and fish in some cases. And only a portion of the stand needs to be in standing water. Schoenoplectus prefers low nutrient substrates, will grow in deeper, more exposed locations, has a lower stem density often, and is always found in standing water. And the Schoenoplectus provides food and habitat for birds, mammals, invertebrates, and fish. So our research questions were, how do fish community assemblages compare between Phragmites, Typha, and Schoenoplectus? And how does the habitat vary in these three vegetation types? So in our study, we looked at 16 sites across 3 of the Great Lakes. So we had some sites in the Bay of Quinte area of Lake Ontario, a few locations in Lake Erie, Turkey Point, Long Point, and Rondo Bay, and then some locations in the Walpole Island area of Lake St. Clair, and also in Georgian Bay in the Severn Sound area. So because of well-known regional differences in water quality and habitat variables, we chose a paired sampling design so that we would be only looking at Phragmites, Typha, and Schoenoplectus within a site instead of comparing it across regions, because we know those regional differences are quite pronounced. So each sampling location had all 3 vegetation types within a 2-kilometer radius, but there were a few sites that had only Phragmites and Typha. Sites were sampled in July and August of 2018. And if you remember, that was a summer of high water following more than a decade of low water. So the emergent vegetation had expanded during those low water years and had become flooded in the subsequent high water years. So for our study design, we used fyke nets to assess the fish community, and they were set with the wings and the leads in the emergent vegetation. So we were sure that any fish that ended up in the fyke net were there because they had been within the vegetation. So each site consisted of at least 2 of the 3 vegetation types, and 2 nets were set in each vegetation type. So 2 nets would be set in the Typha, 2 in Schoenoplectus, 2 in Phragmites within a 2-kilometer radius. Vegetation surveys were conducted along the lead using quadrats, and a DO logger and a light logger were positioned along the lead as well. YSI sonde was used to measure basic water quality variables. So I'm going to talk first about the habitat metrics. So we looked at a suite of water quality variables, some vegetation parameters like stem density, percent cover, and number of other plant species growing within that vegetation stand, and also some habitat variables like slope, the light levels, and the depth. So I'm quickly going to talk about some regional differences to kind of frame how our study was was set up. So as we know, temperature in the more northerly sites is going to be lower than the southern sites. So we could see that with our data. Conductivity was lower in Walpole Island and Georgian Bay, and higher in Lake Ontario and Lake Erie. And pH was lowest in Lake Erie and higher in Lake Ontario and Walpole. And dissolved oxygen was lowest in Lake Erie, and Lake Ontario and Walpole had higher dissolved oxygen. So again, because of those regional differences, we use the paired design to account for that. So looking at the water depth, where the vegetation was growing, so Schoenoplectus consistently was growing in deeper water, which was as to be expected. We also found that the dissolved oxygen was higher within the Schoenoplectus stands compared to Phragmites and Typha. And the number of other plant species was higher in Typha compared to Phragmites and Schoenoplectus. And not surprisingly, stem density was highest in Phragmites compared to Schoenoplectus and Typha vegetation. So looking at the diurnal figure of dissolved oxygen, the three different panels show the three vegetation types. The darker gray bands on the outside indicate nighttime, the white is during the day. So we're seeing the expected or typical trend in dissolved oxygen, where it's lowest during the morning, the early morning, and highest during late afternoon and evening. But the thing that stands out the most here is throughout the day in the Schoenoplectus vegetation, the dissolved oxygen values don't change too much. And in general, the sample variability is much lower in the Schoenoplectus vegetation compared to Phragmites and Typha. And again, just another way to display that dissolved oxygen data. So this is looking at the proportion of time or proportion of samples that were in either anoxic conditions, so below 3 milligrams per liter, low dissolved oxygen, so between 3 and 6, and then above 6 milligrams per liter. So again, the Schoenoplectus stands out because there were no instances of anoxic conditions throughout the day in the Schoenoplectus vegetation, whereas with Phragmites and Typha, there were a proportion of the time where conditions were anoxic and another proportion where they were low dissolved oxygen. And this figure is showing temperature variability throughout the day, the same diurnal pattern, and not much difference between the vegetation types, only a slight difference in variability in the samples, in Schoenoplectus having a lower variability. So when we look at the habitat, all the habitat metrics, and we compare Phragmites and Schoenoplectus, in general, there were more differences between the habitat in Phragmites and Schoenoplectus compared to Schoenoplectus and Typha, or Phragmites and Typha. So in general, Phragmites and Typha would be considered to be more similar than Phragmites and Schoenoplectus. So now we're going to move on to what we found with the fish community in our study. So in general, there was little difference in the catch per unit effort between the three vegetation types, same with species richness. But we did see a difference in biomass per unit effort, where there was lower BPUE in Schoenoplectus compared to Phragmites and Typha. We also looked at family guilds, and when we broke it down by families, there was a greater proportion of Cyprinids found in Schoenoplectus vegetation and a lower proportion of Centrarchids in Schoenoplectus vegetation. So we can look at that a little different way here. So this is the Centrarchids on the left. We can see that there was a higher percentage of Centrarchids in Phragmites and Typha. So that's the Phragmites is the dark blue bands, and the Typha is the light blue. And then on the right-hand side, there's a higher proportion of Cyprinids in the Schoenoplectus, which is that medium blue. And we also did non-metric multidimensional scaling to look at the fish community. And we can see that the Schoenoplectus community is unique from the Phragmites community by the fact that the ellipses don't overlap. So though there's more of the Cyprinids associated with that Schoenoplectus vegetation, which is kind of driving that distinction that we're seeing. We also, coming back to those regional differences, when we look at the fish community by region, Lake Erie stands out, and that's largely due to the fact that there were some fish species found in Lake Erie that weren't found in any other of the sampling locations, which kind of derived that the ordination. And so those were species like warmouth that was only found in Lake Erie. So when we look at that difference that we're seeing with Cyprinids found more in Schoenoplectus and Centrarchids found more in the Phragmites, we know that Cyprinids, with their tendency to school, prefer less dense vegetation with higher dissolved oxygen. And Centrarchids, with their deeper bodies and dorsal spines, are better able to forage in dense vegetation and avoid ambush predators that are often found there. So, for example, pumpkin seed and bluegill are also known to be pretty tolerant of low dissolved oxygen, which will allow them to utilize the dense vegetation that experiences periods of low DO during the day. So just some conclusions. So we know in a high water level year that the fish community assemblage is different in Schoenoplectus compared to Phragmites and Typha. And Schoenoplectus habitats may be very important for fish communities, and its loss from a wetland would have obvious negative consequences. We know that there were no differences in species richness or catch per unit effort across the three vegetation types. And Phragmites does provide some fish habitat, but not all fish habitat is created equal, and not all fish species will use Phragmites. And we did notice that there were noticeable differences in measured habitat variables. So some applications for this research. So targeted Phragmites control to reestablish fish species in certain areas. We know that we can't remove all invasive Phragmites, so a targeted approach in areas where we want to reestablish certain fish species may be the best approach. And we want to prevent Phragmites expansion to areas that provide habitat for a diversity of fish species. So we can also use this information to prevent further expansion to areas that have a diversity of emergent plant species that provide habitat for a diversity of fish species. So whenever you answer one question, it leads to more questions. So what is the fish community like in areas where there is only Phragmites? And does Phragmites provide habitat in low water level years? So we looked at sites with vegetation types within 2 kilometers, but what if there was only Phragmites at a wetland without any other vegetation types? Would we see Cyprinids using that Phragmites because that's the only emergent habitat that's available, or would those species not be there? And by chance, our sampling this year in 2018 happened in a year of high water, followed by a decade or more of low water. So would the conclusion be the same in a low water year or after several years of sustained high water? So I'd like to say thank you to the amazing support from our partners at Walpole Island Heritage Center and to all the field staff and summer students at GLPC. Our funding was provided by the Fisheries and Oceans Aquatic Invasive Species Program. And I'll hand it back to you guys.
Thank you so much. Just a reminder, we'll take questions at the end, but you can, if you have a question for Melanie, still feel free to put in the chat box. We're keeping an eye on them, but we're just going to go right into our second presentation just to ensure we have time. So thank you, Melanie. Prabha, take it away.
Okay. Can you see my screen?
Yep, and it's in presentation mode. It looks good.
Okay, great, thanks. So thank you for joining today. I'm Prabha Rupasinghe, and I'll be talking about our efforts on mapping invasive Phragmites in Lake Erie wetlands using multispectral satellite images. Phragmites australis, or European common reed, is invasive grass that's commonly found in wetlands of temperate and tropical regions. Once it's established, it forms dense monocultures and it can outcompete the native vegetation. So that means it's gonna reduce habitat for the species that utilize these wetlands. Yeah, so management of Phragmites had been a big trouble in the past few decades, because once it's established, it's so hard to eradicate them completely. So the Phragmites management is basically done with herbicide application, as well as cutting, rolling, burning, and many different methods. And unfortunately, there's no biological control method. So for any of these control, we need to know where exactly Phragmites is in these wetlands or wherever it's invaded. And we need to know how widespread or dense Phragmites is. And this is especially problematic if you are considering a large wetland with limited access, because in large wetlands where Phragmites have been invaded, the control is done through aerial spraying. So they use aerial or aircrafts and then take the herbicides in it and use automated spraying program. For this, we need to know exactly where Phragmites is. And also we need to have estimation of Phragmites biomass so that enough herbicides would be carried. So for all these purposes, we need accurate maps of Phragmites. And that's where my work came in. So we try to map Phragmites in wetlands of Lake Erie in Ontario. So the first half of the presentation today, I'll be addressing some efforts on mapping Phragmites using free satellite image data. And also we explored when exactly to collect images for these mapping programs throughout the year. And then what spectral bands that need to be considered in this mapping program. And then also what are the other native wetland vegetation classes that could confuse with Phragmites when we try to map them. And then the second half of the presentation would be on the Phragmites stand specific characteristics that are important in mapping Phragmites. So here we try to address two questions. The first one is, can we map smaller Phragmites patches, even the ones that are smaller than the spatial resolution of an image? And also what's these Phragmites patch characteristics, such as how many individual plants should be there per pixel so that it would be recognized as a Phragmites stand, and also how large a Phragmites individual plant should be, how tall or how large it should be. So to address these questions, we selected 3 wetlands in Lake Erie in Canada. The first wetland is the Toronto Bay Marsh. To talk a little bit about this site, so it's been treated for Phragmites for many years now, but still it has very dense Phragmites stands despite the treatment efforts. And then we have 2 wetlands from the Long Pine National Park. The first one is Big Creek. By the time that we did this study, Phragmites stands in Big Creek were really dense, and there had been like minimum Phragmites controlling efforts in there, so the very dense Phragmites standing there. And then we have Crown Marsh. Even though it's very close to Big Creek, it's being treated for Phragmites very frequently, so it has very small, less density Phragmites stands, so a variation of Phragmites stands in this study. The first, we try to find what images would be best in these mapping efforts. The first option we considered was Landsat 7 and 8. So this is owned by USGS, and it's free data. That's the most important point. We get image once in every 2 weeks. The only limitation is it's 30 meter resolution. That means anything smaller than 30 meter by 30 meter square, we wouldn't be able to see those information. The second option is the Sentinel-2. This is again free satellite data from European Space Agency. So it's better resolution when compared to Landsat. It has 10 meter, 20, and 60 meter resolution band. So a little bit more information in these images compared to Landsat. Then finally, we have WorldView 2 and 3 images. So these are commercial satellite data. It's owned by Digital Globe. So this is the highest resolution available for multispectral data at this point. It's 1.8 meters for WorldView 2 and 1.2 for WorldView 3. So pretty high resolution, good data set. So first we try to see what time is best for mapping Phragmites. So for this, we used freely available satellite data from Landsat and Sentinel-2 because we needed to see time series of images that's collected in every month of the year. So this is example of one of the data sets that we use. So unfortunately, we didn't have like a continuous annual cycle here because of lack of cloud-free images, but at least we were able to cover the 4 seasons. So here the target is to determine the best phenological stage where Phragmites stands out from its neighboring vegetation. So for ground truthing for this study came from a UAV image that's 8 centimeter resolution, so very high resolution image, and also some field sampling. So then we try to see how Phragmites reflectance signal differ from rest of the vegetation. Here we use the method called Jeffrey's metastata separability analysis. What we do here is we take the images, the time series of images, and we compare the signature of Phragmites with all the other classes that we consider in our mapping program. So if the separability is 0, that means the 2 classes that we are comparing is very similar spectrally, so we won't be able to distinguish them separately. And if it is 2, that's the maximum. That means these classes are so different, so the accuracy between mapping of these 2 classes would be good. So when we compared this separability index for Phragmites with other neighboring classes, we found cattail and meadowmarsh to be most confused with Phragmites. But in the summer months, we found mostly in July, August period, this separability goes up. So that means that would be the time that Phragmites would stand out from these confused classes. To consider why this confusion would be, when you compare cattail and Phragmites, you can see they are kind of similar texture, similar height, and similar color kind of thing. So their signal is very similar in satellite images. When we compare meadowmarsh with Phragmites, we can see they are kind of different when compared to cattail, but These two classes are confused mostly because they exist as mixed stands, and also meadow marsh is mostly grass species, so it's tend to confuse with Phragmites. So then we try to use this knowledge and try to do mapping of Phragmites in our time series images. We tested several image classification methods and found support for machines or SVM classification to do best in these images. And we, to be consistent with what we found from the Jefferies Medusita separability, we found that the late summer and early fall period classification to give best classification accuracies in terms of both overall as well as Phragmites accuracy. And we found Sentinel-2 to provide best accuracy, obviously because it has higher resolution when compared to Landsat data. We also looked at what image bands would contribute into separation of these Phragmites signal. And we found that green near-infrared and shortwave infrared signal in the summer, like July and August period, to give best separation between these three confused classes. So these bands would be very important if you are planning to do Phragmites mapping. So that's about mapping Phragmites with free satellite data, just the dense stands. So then we tried to expand this study into a second version where we wanted to look at what's the minimum detectable size and cover of a Phragmites stand when we try to map. This study came up because treatment of Phragmites is most effective when these stands are small and sparsely distributed. So if we can detect these small Phragmites stands, it would be less costly and it would be more effective in the treatment. So we try to explore some remote sensing based method to detect these small stands, as well as we wanted to determine what kind of stands we are actually mapping and what would be missed in our mapping program. For this study, we conducted some field sampling specifically designed for this study. So we conducted fieldwork in Big Creek and Crown Marsh. We used 1.5 by 1.5 meter quadrat. And then we did stem counts of Phragmites in these quadrats and then also recorded the percent cover. After this, we cut off all the Phragmites stands within the quadrat, and then we take the height and weight of the Phragmites. And for the Rondo Bay, we didn't do fieldwork ourselves. We got a nice data set from Trent University where they collected stem count data for many quadrats for their turtle tracking work. Just to summarize what we did in this study, here we used worldview data because we wanted to see all these small Phragmites stand, and that's the highest resolution images that we had with us. And also we wanted to explore the use of Sentinel-2 because it's free data. So basic image pre-processing, radiometric and atmospheric corrections. And rather than going for direct image classification as we did in the previous study, here we try to use a new technique called subpixel image classification that goes through two steps. The first one is the minimum noise fraction transformation, and then the MTMF or the mixture tune match filtering. So I'll talk about this technique a little bit in next slide. So we do this extra step, and then we go for hard classifier. We explored again the support vector machines classification, just like we did before. And also we tested the use of maximum likelihood classification. To talk a little bit about spectral unmixing and MTMF, what this subpixel classification is. So if we have several vegetation or land cover classes that has unique signals within one pixel, the output signal would be a mixed one. So the assumption here is if this mixing of spectral signature happens in large scale, this is a linear mixing. So to explain this graphically a little bit more, so let's say we have three classes within the pixel with three unique signals. And in remote sensing, these unique signals are called the n-number spectrums. The resultant spectrum of this pixel would be a weighted average of all these three classes or the land cover types. So if you're interested in class C, we won't be able to see it in this mixed signal, and this signal has mostly the class B. So this pixel would be most likely classified as class B, and we would miss class C in here. So in subpixel image classification technique, we try to decompose this mixed signal backwards and try to get the percentage of the class that we are interested in. So the objective here is if there's Phragmites a little bit in a pixel, then we would miss this part. So we have this image like a true color image in here with some Phragmites tagged in here. This bluish green color patch is a Phragmites. And after all these image transformations, we would get this grayscale image, which has MF score. So this is a score that corresponds to the percentage of Phragmites within a pixel. So if the pixel is 100% Phragmites, then it would have higher value and it would appear whitish color. And if it has less Phragmites, then the pixel would appear darker in color. So this image has more information in terms of Phragmites cover than a regular satellite image. So with that, we tested the classification afterwards with support vector machines and the maximum likelihood classification method. And we found that Sentinel-2 images after all these transformation and support vector machine classification to give highest mapping accuracy. And the worldview worked best with the maximum likelihood classification. And we compare the classification accuracies of these sensors. We found that maximum likelihood to do way better job than compared to Sentinel-2 images, obviously because it has very high spatial resolution. And then we try to compare the mapping accuracies with the percent cover of Phragmites and the stem count data that we collected in the field. And when we compare the worldview 3 data where we use maximum likelihood classification, if the Phragmites stand was at least 20% or more within a quadrant, then it was mapped over 80% accuracy. So Crown Marsh is the site that we had less density Phragmites, so it has to be at least 60% cover to be detected over 80% accuracy. And for Rondo, we didn't have the percent cover data because this data was not specifically collected for our study, but we have the live stem counts, and we found with worldview, if there's at least 25 stems within a pixel, then it would be detected accurately. And Sentinel-2 obviously had lower accuracy levels for Crown Marsh and Rondo, but for Big Creek, because it had very dense Phragmites stands, still we were able to detect Phragmites cover over 20%. We also looked at mapping accuracies depending on Phragmites height and rate. And for Big Creek, because again, it's very dense Phragmites stands, even with Sentinel-2, we were able to map Phragmites stands if they are at least 1 meter tall. And for Crown Marsh, it had to be at least 2 meters tall. And then weight-wise, again, pretty accurate in Big Creek because of the dense stands. And then Crown Marsh, it's little less. And it's even lower when we try to map it with Sentinel-2 images. To compare why this difference is like, so this is what I've been talking about in Crown Marsh because of the management practices. The Phragmites stands look like this. So these are very small, less dense stands. So it was difficult to capture them, but at least we were able to capture some of these. So that was good. And then in Big Creek, so this is what Phragmites look like. So it's very dense and very large. So it was way easier mapping when compared to Crown Marsh. So just to summarize what I've been talking about, so we were able to use free satellite data with simple image classification procedures to detect Phragmites, at least the dense big patches. So this is very useful because this data is free and we can do this repeatedly and also can look at the free, treatment effectiveness and how Phragmites distribution would change over time. And then we also try to quantify the Phragmites stand characteristics that are detected through remote sensing based techniques. This is because we wanted to minimize the omission error. So that's very important for effective treatment. So if we miss a Phragmites stand, the chances are it would grow back and then it would invade the treated area again. So again, so if we can detect these small, young, dense, less dense Phragmites patches, at the early stages of invasion, the treatment efforts would be way more effective. So we collaborated with NCC, the Nature Conservancy of Canada, and Canadian Wildlife Services last year, and we extended this mapping program for entire Long Point region, and we were able to accurately map Phragmites stands in these wetlands, and those were actually being used for these Phragmites spraying programs, which is really good. So with that, I would like to thank my supervisor and also the co-author of the two studies that I presented today, Dr. Patricia Cho-Fraser from McMaster University, and also Dr. James Marcaccio and Dr. Chantel Markle, two former PhD students from our lab who had been working with Phragmites, and their work had been a great help for my research. And also Jennifer Ango and Dr. Christina Davy from Trent University, who collaborated with us for the Rondo Bay mapping program, and also Nature Conservancy of Canada, Ministry of Transportation, Ontario Ministry of Natural Resources and Forestry, and NSERC, the agencies who funded this program, and also Ontario Parks and Wildlife Services, who granted permission to conduct field work in these wetlands. Thank you so much for listening, and I would take any questions that you may have. Thank you.
Thank you so much. That was an impressive amount of information to get through so quickly. So, as she mentioned, we have finished both of our presentations. So we will take questions for both of our presenters, and you can just type them into the chat box since everybody is muted. But while that, we just want to, before we get into questions, just thank you both for presenting. Here's their contact information. I'm sure they're happy to, if you think of a question tomorrow, I'm sure they're happy to answer any questions about their work. All right. So since we'll start with two questions for Melanie first, and since she had our presentation. Let me make sure I can see you guys. One second. Okay. So Melanie, we have a question. How long did your research study last from start to end, and what type of nets did you use? So mesh size, and why did you decide on that?
So I answered that just a minute ago in the chat, but I can say it too. So it was only July and August of 2018. So July 12th to August 24th. And yeah, so a limited study, but that's just the way sometimes it goes when you're going by how much funding you have. And so we used fike nets. The leads were 7.6 meters long and the wings were 3.6 meters long with a mesh size of 4.8 millimeters. So, could capture from, some pretty small fish to, pretty big fish. The advantage of going second is I could look these answers up because I don't have those measurements on the top of my head.
Yeah. And then there was a second part to their question too, and you might have answered it in the chat, so I apologize, but were you aware of any other patterns for other fish / types of fish?
So we did look at a bunch of other parameters as well, but we didn't percent piscivores, percent insectivore, percent planktivores, a whole suite of other groupings for the fish, and didn't find anything that kind of stood out, anything that was significant beyond the Cyprinids and the Centrarchids. But when you dive into that species, the individual species, there are some species differences that I think it was a black chin shiner that was only ever found in Schoenoplectus vegetation. But I can send a link to that, to our paper, and in the supplemental material is the catch per unit effort by vegetation type and region. So you can kind of see that.
Awesome. And this was another question from Sophie. I don't know if you mentioned answered it in the chat already, but if you want to add on more, feel free. Do you believe Phragmites stands are providing equally suitable habitat for Centrarchid species when compared to similar locations with native? I don't know if you've done any work with native Phragmites stands, but.
Can you just repeat that?
Yeah. Do you believe Phragmites stands are providing equally suitable habitat for Centrarchid species when compared to similar locations with native Phragmites?
So we didn't when we did the study, we didn't distinguish between native Phragmites and invasive Phragmites. So we were with the study, we were more looking at the structure of the habitat,
Sure.
not so much the species. So looking at dense tubular, which would be the Phragmites, versus sparse tubular, which would be Schoenoplectus, and then dense, like broader leaf vegetation, so which would be the Typha. So, from a fish's perspective, if you think like a fish, they're likely looking at the structure, not so much the what species it is. So I think the differences that we saw were related to that structure, like the density of the Phragmites meant that it wasn't suitable for many of the Cyprinids, but it was adequate for some of the Centrarchids.
Makes sense.
I don't know if that answered your question or not.
And now Prabha, we got some for you. So we have a question to confirm. It was free to access the privately owned Worldview satellite imagery. I guess I want to know more about that.
Yeah, Worldview data is not free, so you have to pay for those data. But Landsat and Sentinel-2 are available for anyone. You just have to create an account. You can just download images.
Perfect. We have a question for Rob, also for you. Do you have any recommendations for managers who may want to map Phragmites as part of an early detection effort? So that's really relevant to what you're doing.
Yeah, so it's really good if you can map Phragmites in the early stages. So if you can use the second part of my talk, like the subpixel image classification methods, we were able to capture more Phragmites stands, like even the smaller ones, when compared to the mapping efforts that we did with these just the basic image classification efforts. So this paper, I can share it with you. So if you can repeat these classification procedures, you should be able to map smaller Phragmites stands comparatively. So that would be very useful for management.
Yeah.
Yes.
So yeah, I just want to reiterate that there's email is on this page. So it sounds like some of you guys have specific questions. So I would encourage you, feel free to email them if you want any more information like papers.
Yeah.
Another one for you from Connor. Have you tried applying these classifiers to any areas outside of your 3 sites you mentioned? For percent cover, well, we'll stick with that question first.
So for wetlands wise, I only tried it for the 3 wetlands that I showed, and we extended this for the entire Long Point wetlands later on, because we collaborated with the Nature Conservancy of Canada. So those are the wetlands that we worked on, and I also worked on mapping Phragmites on the roadsides. So we use Sentinel-2 images for that. That's one study. So here, I didn't present those work here. So it was done in collaboration with Dr. James Moccaccio. So he's a former PhD student of our lab. He did lots of mapping on roadsides and with aerial images. For me, I tried to do it with satellite images from Sentinel-2. Initially, the accuracy levels were low, but we found that when we combine 2 phenological stages of Phragmites rather than just taking one image, we were able to get pretty good accuracy in the roadsides. But we didn't work on any other wetlands in particular.
Thank you. And there's like a part 2 to this question. For percent cover of Phragmites needed for identification, Were there any even number of plots? Were there an even number of plots per percent cover class?
So not really. So I can check the numbers. I had them in the presentation. I can't remember the numbers exactly. So for the Big Creek, we had like 58 quadrats, and for Crown Marsh, we had 89 quadrats. And for Rondo, we had over 300 quadrats from turtle tracking data. So pretty good data set.
Yeah. And then we have a questions kind of for both and a little bit more. We'll kind of end with this one unless you guys put any more in the chat box. It's like a two-part. So how did you both get into Phragmites research? And what are some research that you think is most needed in the Phragmites field? We have aspiring scientists out here.
So I guess I got into doing Phragmites research because of my background with other wetland vegetation, like developing an index to determine the quality of a wetland based on the plants that we find there. Yeah, so that was kind of, I guess, how I got into it. And my current supervisor, he knew of my work, and that's how I kind of got that project. So yeah.
For me, I have background in botany, and I used to work with invasive species back in Sri Lanka when I was doing undergrad, and then I moved towards remote sensing and worked on remote sensing of vegetation. And for my master's work, I worked on mapping wetland and the shoreline vegetation in the Lake Erie on the US side. So then when I wanted to move for a PhD, I had background both on plants, invasives, and remote sensing. And then I contacted my supervisor, Dr. Pat Chofres, and she was looking for someone with these specialties to map Phragmites. She wanted to extend her research on mapping Phragmites. So that's how I specifically got into the lab and then started working on Phragmites mapping. Yeah.
Thank you. Okay, I think I don't see any more questions, but again, I'll encourage it again if you guys have questions for both of our presenters today. I'm sure they're more than happy to reach back out to you. And I just wanted to reiterate that a recording of today's webinar, so if you wanted to review some of their work or share it with anybody, will be shared on the Eventbrite. So when you guys registered, you'll get a follow-up email saying that here's the webinar recording. You could also view it on our website next week. And we do have one more upcoming webinar for our 2022 series. So this will be May 10th. So next month at 10:30 Eastern, we'll have Dr. Pingong of the U.S. Army Corps of Engineers, and he'll be sharing his work on Phragmites gene silencing. So that should be really interesting. And the registration will be available soon on our website, so feel free to check that out. And we just wanted to acknowledge the U.S. Geological Survey and the Great Lakes Restoration Initiative for providing funding that we're able for the collaborative and for us to do these webinars. And as a reminder, the webinar will be posted in a few days. And I just wanted to thank you both for taking time to share your work. It was fun to have two presenters just pack it in for an hour. So thank you both.
Thank you for having us.
Yeah, thank you for the opportunity.
Yeah. All right, if you have any additional follow-up questions or comments, you can feel free to email us at phragmites@glc.org. And if not, thank you again, everyone, and we hope everyone has a wonderful day.